Okay, here's our video on triangles. So we all know what a triangle is. It has 3 sides and it has 3 angles. And we can use this little kind of half circle to represent an angle. So it has 3 sides and it has 3 angles. So we can classify triangles, we can name them by the angles or the sides. So those are ways we can identify them, by the angles or the sides. And we can also identify them by a combination of both. So first we'll talk about triangles where we can measure their degrees. And when we measure their degrees, that's their angles. Not angels, angles. Okay, so we'll use a protractor. Now a protractor, we can measure degrees. And you can see this protractor makes a half of a circle. So a protractor with a half circle is 180 degrees. The total degrees is 180. So a circle would be 360 degrees. And we use this little sign. So a circle, would be a circle, is 360 degrees. And we put that little 0. It's not an exponent, it just represents degree. So this is, a circle is 360 degrees. Now a triangle, the maximum degrees of a triangle would be 180 in any combination. And we'll go over that again. So let's look at our first triangle. It's called a right triangle, and it's 90 degrees. Notice it has that little box right here. That represents that it's 90 degrees. So it looks like an L. Now it doesn't have to be that way. It can also be this way. Right? As long as it has that little box, we know it's 90 degrees. Right? It could be in any way too. Like I can make it like this. Right? I can have it upside down. Right? I can turn it any way. Right? We just know that this line and this line are completely straight. So any way you look at it, it's going to be 90 degrees as long as you see that box. So again, it could be this way, it could be this way. This is a right angle. And another name for a right angle, again, is a 90-degree angle. Looks like an L. We also have an acute angle. Right? Not acute angle, but an acute angle. An acute angle is less than 90 degrees, as you can see here. So if this is the right angle, and the only thing missing here is that little box, remember, that's a right angle. The acute angle is just less than that. So a right angle is 90 degrees, and an acute angle could be anything less than 90 degrees. So we can just say, oh, maybe this is 45 degrees. Well, that'll be an acute angle. Or maybe we have something that's 30 degrees. That's an acute angle. So what if I made an angle like this and it was 50 degrees? Is that an acute angle? Yes, it's 50 degrees. It's less than 90. Anything less than 90 is an acute angle. Okay? Now anything more than 90 degrees, but less than 180 would be an obtuse angle. So this is obtuse. Obtuse. So obtuse angles, they're greater than 90, but they're not 180 degrees. Because 180 degrees is a straight line. That's 180 degrees. So a straight line is 180 degrees. We call it a straight angle. So far we have a right angle, we have an acute angle, and an obtuse angle. And also the straight angle, which is 180 degrees. Now anything more than 180 degrees we'll talk about in another video. That's called a reflex angle. Okay, so now we could also measure triangles by their lengths. So here we have an equilateral triangle. And it's easy to remember. Equilateral triangles have the same length. So let's say this was 3, 3, 3. They have the same lengths. Let's say this was 3 centimeters or whatever. They have the same lengths. That's why it's called equilateral. Then we have an isosceles triangle. Isosceles triangles have 2 lengths the same. One length is not the same. So isosceles, think of two things. Some students in the past thought of the Greek hero Hercules, and Hercules and Isosceles sound the same, and that's two people. So think of Isosceles and Hercules, and that's two sides are the same. So let me draw a bigger triangle here. Again, we can have a triangle like this, and let's say this was 10 units and that was 10 units. Well, this one, let's say, was 9 units. Then you have an isosceles triangle. Right, and if I put like these half circles here, right, that represents the degrees. Now on an isosceles triangle, two angles are the same, so we can put those slashes like that. Let me write that over so you can understand that. With an equilateral triangle, they're all the same, so you can put a slash like that. These slashes, the one slash in each of the sides, says that they're all the same. If I put two slashes here, then we're saying that only two sides are the same and one's different. So this would be an isosceles triangle. If I got rid of that slash, now we have an equilateral triangle. So keep that in mind. The next one is called scalene. And a good way to remember this is scalene is mean. No sides are the same. So let's say this was 9. If you can't see those numbers, none of the sides are the same in scalene. So let me just make it bigger here. So if you saw something like this, these dashes are saying that none of the sides are the same. Now we can also combine the lengths and the angles to identify triangles. So the first one we'll look at is an acute equilateral. And remember, acute angles are less than 90 degrees. And equilaterals are all the same. So here we have an acute equilateral triangle. All the degrees are the same. All the sides are the same. You can see these slashes. This is called an acute equilateral. Now we have a right isosceles. That's another way we can identify it. It looks like a right angle. Has that box, 90-degree box. And the other two angles are different. They're 45 degrees. So we have 2 degrees that are the same. 1 degree is different because it's 90. And we can also have, since it's isosceles, 2 of the sides must be the same with those slashes. That's a right isosceles. And then we have an obtuse scalene. Remember, obtuse is greater than 90 degrees, but not 180. So I'll make it bigger here for you. I have a degree, something like this. And these slashes mean that none of the lengths are the same. And this could be 40 degrees. This could be 110 degrees. And this could be 30 degrees. So none of the angles are the same. None of the degrees are the same. Angles and degrees. And none of the lengths are the same. So that's an obtuse triangle. So those are the triangles. That's how we identify it. And remember, when you add up the degrees in a triangle, it has to equal 180 degrees. For example, if you look at this obtuse scalene triangle, it has 110, has 40, and it has 30, and that equals 180. So the degrees have to equal 180. Okay, and if I'll give you another example. When we had the right isosceles, we have 90, 45, and 45, and that equals 180. So remember, triangles equal 180 degrees. Great job.